The statistical tests.xlsx file is a collection of statistical tests that the green belt or the black belt is likely to come across in their process improvement career. And one of the features in this file is the hypothesis testing roadmap. I just want to briefly go over the roadmap. Here we start, and the first question we ask, what we are asked to answer is the Y, the output, the process output, is it variable or attribute data? And if it's attribute, then you make your way over into this area, and all of the tests associated with attribute data are here colored in blue. If, though, the answer is no, it's variable data, then we ask whether or not you have multiple access, and if you do, then we drop down into this area where we've got DOE, multiple regression, multifactor ANOVA, etc. But most of them will be single axis, and if those single axis, that single X tests out to be normal using a normality test, then we make our way down into the area where the cells are colored, or the balloons are colored green, and these tests are also all associated with normally distributed data. And then similarly, if the data is not normal, which does commonly happen, then you will end up over in this area where all of the balloons are colored yellow for non-normal data. And then there's a few other commonly used tests that don't sit necessarily nicely into this kind of format. The runs test, the two-key quick test, or the N-count test it's known as, is another one. Now, there's a matrix in this file, and the matrix proposes to have many of these tests listed across the top here. The test parameters, so what is a one sample Z test for? Well, it's a test of means. And a one proportion test is a test of proportions, and so forth. And then down below that we've got some assumptions that some of these tests make. And so, for example, one of the assumptions for a one sample Z test is that you've got variable data. Wilcoxon rank sum test, one of the assumptions is that the samples have the same shape and spread, for example. So this is another way of just helping you check in to make sure that the test you're using matches the data that you have. And then finally, I wanted to go over to just one of the tests as an example. I'm here in the two sample T test. And like all of our templates, wherever you see yellow, these are data inputs, and so I'm going to put data in for my group data A, or group data 1, and group 2. I then construct my hypothesis statements. In this case, there's no difference. Maybe I'm testing for the means because I'm doing a two sample T test. So there is no difference in the population means. There is a difference in the means, and perhaps I'm testing that one is less than the other. And you'll notice that as I change this, whether or not it's a one or two tail test, it changes as well. Then I pick my confidence level and the test difference, if that's appropriate for the test. And then I got a number of varying statistics along with that. So X bar 1 is the mean of data set 1 and the mean of data set 2. And what you want to do then is notice what decision to be made. So the decision is reject the null. So the null hypothesis is that there is no difference, and we reject that null. Alternatively, the answer is also over here. This is just a repeat, and the answer will show in blue. So we've got a one-tailed test as indicated by a less than or greater than hypothesis. P-value 0.019. We see that that's less than my alpha of 0.05, and therefore we reject the null. And of course, we get the same answer. Now, if I were to just change the test, you can see that if this were a test of non-equality, it's a two-tailed test, and we get the answer highlighted here in blue. So that is the statistical tests file. It's very, very useful. Very useful. Pardon me. It's not meant to be a substitute for commercially available statistical packages or software, but it is very convenient in as much as you can see the calculations behind each of these tests, and the results you get here should be pretty consistent with commercial software.